Hello there. In this lecture, we'll continue discussing different ways of generating data. More precisely, we'll go over new methods we can use to generate specific kinds of data, like integers and probabilities. Let's get started. If you recall, last time we imported NumPy's generator function and the PCG 64-bit generator, and then created a generator object with a fixed seed. Since these seeds reset after every execution, we're going to start by redefining the variable once again and setting its seed back to 365. Great job! Now that we're all set up, we're ready to examine the integers method. As the name suggests, it generates whole numbers, also known as integers. The method requires defining a fixed range of values to choose from. If we only provide a single value, like 10, it automatically assumes we only want integers between 0 and 10, excluding the value we passed. To see this in practice, simply type array_rg.integers and add the upper limit and the size of the desired output. We see an array containing only the whole numbers from 0 to 9, which is exactly what we expected. Of course, if we want to shift the goalposts and change the interval, we just need to pass values to the low and high arguments. For the sake of practice, we can set the former to 10 and the latter to 100 before rerunning the cell. The result is a 5x5 matrix full of two-digit numbers, so the model works as intended. Splendid work! In the beginning of the lecture, we said that we'll also show you how to generate probabilities. We do so with the help of the random function. Let's copy the code we just wrote into a new cell and change integers to random. The random method isn't compatible with low and high values, since probabilities are always between 0 and 1. Therefore, we can remove those as well and run the cell. We see a 5x5 matrix full of values between 0 and 1. The values in it are extracted from a continuous uniform distribution. Statistically speaking, this means that getting any of the infinitely many values in the interval is equally likely here. All right, the last method we want to discuss is choice. This method simulates the idea of making an arbitrary choice out of a given sequence, be it a list, array, or tuple. For example, we can examine how the method will fill out an array using a list of 5 values. To do this, simply paste the code from the last cell, change random to choice, and add the list of values as an input argument of the method. The output is another 5x5 matrix, only this time, all the values come from the sequence we've provided. If we haven't specified fixed probabilities for each element, the method defaults to using a discrete uniform distribution. From a statistical sense, this means we have a known finite amount of equally likely possible outcomes. If we believe this shouldn't be the case, we can manually set the probabilities for each value of the sequence. We can do so by passing a sequence to the p argument of the method. However, you need to be careful here, because if the number of elements passed to p does not match the number of choices, or their sum isn't equal to 1, then we'll get a value error. If we've set it properly though, we'll get an array for each of the lists of choices features roughly as many times as estimated. This sounds one bit too complicated. Nevertheless, it is the most useful approach to generating random data. Fantastic! Now that we've learned how to generate arrays of random integers and probabilities, as well as make choice on our behalf, we're ready to move into probability distributions. In the next lecture, we'll discuss how to use the generator's class capabilities to simulate data from a specific type of distribution. Thanks for watching!